Staring at a blank AI input box, it is tempting to treat the machine like a new employee. You want to make sure it understands exactly what you need, so you start typing. Looking at this massive text block, you see the physical effort. You type out background context, exact framing, and rules. You end up with a dense 200-word prompt. Meanwhile, a colleague types a single blunt sentence to ask the exact same question. Comparing the results of these two approaches often yields a surprising result. In many cases, the 40-word sentence produces a sharper, more direct recommendation, while the elaborate paragraph results in a response that feels generic and diluted. We naturally assume that spending more time and using more words results in a more precise set of instructions. Because the prompt looks sophisticated, it feels like it should perform better. This discrepancy reveals a misalignment between human intuition and machine logic. To a transformer architecture, added length frequently obscures the very information it was intended to clarify. If we look closely at the middle of this elaborate prompt, we see commands instructing the model to think carefully, consider multiple perspectives, and provide a balanced view. Modern models are already hardwired to perform these analytical behaviors through their post-training. These are the defaults. Commanding the system to be helpful requests a behavior the model is already trained to provide as a baseline. Telling it to provide accurate information or format the response clearly adds length without adding new information. The model would have performed these actions regardless of the instruction. These instructions can actually be counterproductive. When told to be thorough and consider multiple perspectives, the system often addresses the prompt performatively, generating extra paragraphs to show it's considering things, which dilutes the actual answer. Attempting to coach the system through its job creates a massive amount of meaningless noise. This noise aggressively competes for the model's finite processing power. This noise becomes a structural problem when we look at how the underlying architecture actually scans a block of text. This illustrates the lost in the middle effect. AI models weigh information at the beginning and the end most heavily. The middle receives significantly less attention. In elaborate prompts, users typically bury their core question right in that low attention zone, hidden behind framing. The core question is the signal. Every redundant framing word surrounding it acts as noise, degrading that signal, until the model's capacity is divided across material it didn't need in the first place. Short prompts concentrate the model's full processing capacity on the task itself. By removing the framing, the instruction naturally sits in a high attention position. Length earns its place only when it provides information the model couldn't otherwise know. This includes hard data, unique constraints, or specific few-shot examples that demonstrate a pattern. The diagnostic test for any sentence in a prompt is simple. If the model would have the same information without that sentence, it is overhead that should be removed. Returning to our original prompt, we begin the erasure. We strip away the persona assignments and the requests for the model to act as an advisor. We remove the behavioral coaching and formatting rules, leaving only the core question and specific facts. With the framing removed, the machine's processing capacity is entirely focused on the core task. The signal is clear and the redundant noise is gone. High-quality output depends on the discipline of subtraction. The goal is to provide the model with the necessary information, then get out of the way and let the defaults do their work.